Hi everyone, it's Ono here, and I want to welcome you to the Creative Machine Learning live stream. Today we're going to be taking a look at TensorFlow Lite, how to load it in Python, how to make predictions, and we might take a look at other different topics as well. So I'm gonna get started fairly soon. So when you connect online, I'll invite you to say on the chat where you're connecting from, how you found us, and if you can see me and hear me okay. And I would encourage you to support the channel by liking this video and also to subscribe and click on the bell if you're not subscribed yet and want to get notified when I go live next or when I upload new videos. I am trying to rethink the way in which we select topics for the channel to have a more consistent year in 2023, which is going to be here pretty soon. And also I have the intention, both on the podcast and on the live stream, to make a sort of recap or review of 2022. That means that we'll be maybe in the live stream revisiting some of the highlights of things that we've achieved and done here, maybe compiling those into a summary notebook or in a summary folder that has all of those scripts, because I want to see what we've done. I want to share with you again, and I want to see whether we continue with some of those things and move forward with the live stream with some of those things that we started. Maybe some of them we continue developing because we didn't fully get there last year. All right, so let's get started. So this is just a mention of what we did last week. I did a hands-on coding session with the Raspberry Pi. I had the ML kit for low. This is Live 92. And you can go to that one at this link at nonomath/live/92. I still have the Raspberry Pi here with me. Offline, I was able to actually solve the problem we had the other day by starting from what's called the booster Raspberry image. So that's Debian Booster is the Raspberry Pi OS legacy, it's called, in the Raspberry Imager. And if I installed that one by following the steps that we did last time, we could get TensorFlow Lite installed and running. So I didn't get to run an actual TensorFlow Lite model there yet. That's what we're going to try to do today to basically progress and be able to do that. And I was also able to use the camera API from Python to display the video feed of my webcam live, and also to display strings that, in the same way that we will do if we were to be displaying strings of whatever we have classified. And also mentioned that we have released an episode with Zach Krohn. So this is episode 70 of the Getting Simple podcast. We talk about creativity, art, selling art, some pen plotter art that Zach does with Dynamo BIM, that's Autodesk Dynamo. The creative process, a lot of these, the process that the podcast has evolved in, and many other things. So I would invite you to go on YouTube. You can just watch that video and let me know if you enjoy it. I think it's nice that we were able to release this episode on video, because other episodes we've only released on audio, and now we're trying to release everything with video. Might be recorded remotely or in person, like this one. And here I'm just gonna play a little snippet, and this video shows two things. One, that we have a work in progress episode that's going to be coming pretty soon that is more focused on machine learning on the Getting Simple podcast. So you can go and subscribe to Getting Simple if you want to get notified when that episode goes out. But what I want to show here, and at some point I might show the workflow that I have to do this. This is a little clip from the podcast that I transcribed with OpenAI's Whisper model that we used in, I think, live stream 91 or 90. And I didn't do any edits, right? I just imported that transcript into this script and tried to align it, and then created this audiogram with the audio you can see here. So I'm going to hide myself and I'm gonna just let this play, and hopefully you can hear the audio.
So you're right. There's this encoder-decoder structure. That's the other thing. So things go into this embedding space and they come out of it again. And depending on what task you want to do, you will decode things differently or encode things differently. And what's intriguing about it is that we began at a certain stage. You start to see these emergent behaviors. So the first thing that happened was we started to see that these transformer models were robust to a wide variety of tasks. So training this base model on a large data set and then using it in a supervised way outperformed just training from scratch.
All right, so as you could see on this video, the transcript matches completely what he said, and we have word level timestamps in which each word is highlighted as he's saying it. I think this is really nice. It will allow us to create materials for social media and also as an aid for people who want to follow and maybe are not super versed in English. But yeah, so let's keep going. That's an incoming episode, as I said, and I would encourage you to submit questions about our latest or any previous episodes at gettingsimple.com/ask that I'll be happy to answer here on the live stream or on future podcast episodes. Okay, so I think it's about time that we revisit the goals. It's not going to be on today's live stream probably, but really soon. We have the intention to create a machine intelligence for designers course, right? So I have been thinking about this, and I really like the way in which okay, so this would be like a section for goals, and I missed actually a timestamp for talking about the podcasts. The goals of the live stream, one format that I've seen for the intro to ML course is Aurélien Geron's hands-on machine learning books, support material on the web. He has a GitHub repository where he actually uses the notebooks to storytell what he's going through in terms of algorithms, and also show examples, like hands-on examples with written neural networks and code examples, TensorFlow examples, and scikit-learn examples, and Keras as well. So that's the format that I'm going to try to follow, and I'm going to try to start today from creating these notebooks. I've been creating notebooks before in the live stream, but I want to even go a bit farther and actually document live streams that way. And maybe through creating notebooks, then we can create videos for that course, or like to go through all those examples from scratch and navigate the contents. And, I've been trying to foster the community. I'm reaching out to people who can maybe contact me. I want to have one-on-ones with some people that have been following the live stream. I still have to write to some of you. And I want to really thank everyone who's been there, because it makes it so much better when there's people providing me feedback, also adding links and telling me what the latest developments in AI have been that we can cover on the live stream, and other things like that. And building a collaborative AI sketching platform, I kind of gave up at some point, but we're going to get back at it because I really want to do that. And I think that's going to be I'm going to leave these two as the stretch goals for the live stream in 2023. I'm going to continue with, the three ones on the top, for like creating an intro to ML course for beginners, fostering the community, and creating a collaborative AI sketching platform. The one in the bottom, delegate video post-processing, I'm actually working with Andrea Villalón Paredes from Seville. So she's Spanish, she's studying filmmaking, and she even has her own podcast. And she's been helping me edit the two latest episodes. So if this collaboration works, we're gonna continue producing podcasts this way, and I might have to find a different person for editing video tutorials for the YouTube channel in terms of creative coding and creative machine learning tutorials. But so far, so good. I have progressed in there. And one stretch goal that I have as well is the automation of clips. So I'm gonna show really quickly if you go to youtube.com/nono, so I think you can do nono clips, I've created this new channel that right now it's empty, which is going to feature clips from my podcasts and videos. And if you go to the main channel, I've actually also redesigned and simplified a bit the cover of the main channel. So it's shows Getting Simple here, and it says that we have podcasts on creativity, tech, and culture, and videos on creative machine learning. So I'm trying to figure out a bit the branding of the whole project, because it's really easy for me to create and talk about many different things and jump around, as you might have seen during 2022. But I'm trying to make everything a bit more cohesive and clear to newcomers, especially because you guys, if you've been following the project for a bit longer, you might know how I work already, but people who come from outside might subscribe because I have machine learning videos, but then see that I have a podcast, or subscribe because of the podcast and then see a lot of technical videos, right? I'm also trying to homogenize a bit the covers. So this is going to be the new format for podcast covers, inspired by, I liked how simple Lex Friedman's covers were actually, and I kind of redesigned a bit and make the letter, so the typeface a bit larger, because the one before, like these ones, were a bit too small to read in some YouTube views, and even more now that they've redesigned. So I think these ones that were the old one are depreciated now, and as you can see, I'm uploading covers for some of the other episodes. It's nice that YouTube lets you change at least the album cover or like the video cover even after as much time as it's passed, because that way it allows you to homogenize playlists a bit, even time after you have released the videos, right? So what I'm gonna do, I'm gonna try to homogenize this entire playlist. And I don't think I'll do that with the live playlist because there's too many different cover types. I'm still trying to figure that one out. All right, so this is a sneak peek. So I've been trying with and playing with Stable Diffusion. We showed something on the live stream. I especially liked these sunflower fields with the arcane style fine-tuned model of Stable Diffusion. And I also have this. So I kind of learned how to create these animations that animate the progress of going from step 1 to step like 40 or whatever steps you want to go up to, and then it comes back. It's like a boomerang effect, right? So this is a photo of a banana generation. And yeah, I've been playing around with it a bit more. I'd love to know if you've been playing with this or other models as well. So let me know in the chat, on the comments, or on the Discord server. And yeah, so if you're connected, let us know if you can see me okay, if you can hear me okay, and where you're connecting from. And so let's see what we're gonna do today. I mentioned TensorFlow Lite before, and that's what I'm gonna take a look at. I've put the link to the notebook that I'm gonna be using on the Discord server, so you can join at nono.math/discord and simply go to the live channel, look for Live 93, and then you'll find the links of the things that I'm sharing today, including the calendar link invite, the Calendly invite that you can use to book a meeting slot with me to let me know, what you're doing, why you're watching these things, why you're part of the community, and maybe even what you can contribute to. So so this is an over hands-on session where I'm going to be like typing code to basically predict and conduct inferences with TensorFlow Lite and create code that can run on the Raspberry Pi as well. Swift in iOS and Java in Android devices. This, once you get a model that can run on TensorFlow Lite, on the TensorFlow Lite runtime, you can port it. You've basically ported your model in a language that can then run on edge devices and on cloud instances and many places in a way that is a lot lighter than running TensorFlow TensorFlow Core. All right, so without further ado, let's get coding. Okay. So let's take a look. So here, as I mentioned, I have a notebook. This is a Colab notebook that I have shared. Let's make sure to have shared as anyone with a link, copy link. And I'm gonna set my runtime to GPU. So we reserve GPU, and we're gonna connect to this notebook so we can run code here. So from now on, I'm gonna be coding on this notebook. Everything that I do, you're gonna be able to access it. And I'm gonna put the Discord invite on the chat, so it's not the mass as Discord. If you go to that invite, join that server, and on the live channel, you're gonna be able to see the links, right? So I'm gonna open it here so you see what I'm talking about, and we'll get started, right? So you just go to Getting Simple, Live, and you see, for example, for Live 93, we have these links. For Live 92, we don't have any, but you can see that for previous live streams, I'm always pasting the links here, sometimes with more detail, sometimes with less detail. And yeah, so feel free to go there and access the links. And it helps if you like this video. Don't forget to subscribe and click on the bell if you're gonna get notified when I go live next or when I upload new videos. Let me quickly clean up and archive this thumbnail here, and let's get started. Okay, hi Imahara, nice to see you. You're connecting online with us again, live. What's your time zone? I forgot. Are you the one from the UK or are you the one from India? I forgot right now because there were two people last week. I guess this time works better from the UK than for India, but for India it's sort of okay still. It's not too late. Okay, so let's open our notebook here, and we're gonna start this hands-on coding session where we're gonna be typing code and executing it in Colab. All right, so Imahara is from the UK. Awesome that you're joining us again. So the first thing that I say on this notebook, right? We have a Colab notebook with the code that we're gonna write today. And I mentioned that there are two ways to import TensorFlow Lite. One is with TensorFlow Core, and the second is with TensorFlow Lite Runtime. We don't need to do both, but I'm gonna show how you do that. So you can load the import TensorFlow Runtime from Core. Let me quickly let's go to TensorFlow API documentation. So I have this helper code here, ITF, like this import TensorFlow TF print TensorFlow version, that if we run it, we're gonna see the version of TensorFlow, the version of Python that is running here, and whether we have GPU cards. So we have TensorFlow 2.9, Python 3.8, and we have a Tesla T4 GPU available. TensorFlow V11 is already installed. So we could actually, if you wanted to upgrade to the latest TensorFlow here, we could do here. Let's actually do that. Add that here. Upgrade to latest stable release to latest stable release of TensorFlow. How do we do that? We run this command here. We're gonna do pip install TensorFlow, and we're gonna say upgrade. So this flag to upgrade the package. Let's see what that does. So this is actually doing what I was expecting. So it's downloading TensorFlow 2.11. That's the latest. And I just guess like the default kernels in Colab are 1 or 2 versions behind, just because those versions are more tested and probably are meant to work better. This is also going to add some execution time to the notebook. You can see that, you know, we're downloading huge package, and here we can see how heavy TensorFlow Core is compared to TensorFlow Lite. We're going to see that in a second. So here we're installing TensorFlow for the latest version, I believe. So pip quiet install flag. I believe we can, yeah, so pip offers v verbose and q for quiet. So it's clear for everyone. We can put here quiet, and that way you won't get all this output, even though, you know, sometimes the output is good, because that way you get a sense of progress of how this thing is going, as opposed to just blindly looking at something. The following packages were probably installed, this one, so you must restore the runtime in order to use newly installed versions. So we could do here restart runtime and run all. And, you know, I'm not completely sure how good this is, like, to actually upgrade. I don't think we're gonna notice any changes in the things that we're going to be coding here. But yeah, so this is now quiet, so we're not going to see what happens there. But actually, I think it would be good to see something, because otherwise we don't know what's going on. But yeah, so now we have 2.11, and yeah, everything has run. So actually, even though we've done this, I don't think we need it. I don't think we need to do that. So I'm going to disconnect and delete runtime. Yeah, okay. We're gonna keep what we have. So I'm going to ensure we have GPU. We're gonna reconnect, and we're gonna run all. All right. So I was talking about two ways to load. So 2 ways to load TensorFlow, right? Okay, let me put here one block. Check TensorFlow and Python versions. Here we check TensorFlow course version. What TensorFlow core version is available in the current Colab notebook, as well as the installed Python version, installed version of Python, and whether GPU devices and the GPU devices available. All right, so in here, we just add a code block, we just paste this, and we're gonna see we have 2.9, blah, blah, blah. We delete this block, and then 2 ways to import TensorFlow Lite. All right, again, 2 ways to import TensorFlow Lite. One is with TensorFlow Core, the other one is with TensorFlow Lite runtime. And so the easiest here is to do import TensorFlow as TF. And you know, we already did this here, so we don't really need to do that again. But with TensorFlow Core, I believe, I'm not sure if it's TFLite runtime. Let's try to print this here. TensorFlow, we have the documentation here, TensorFlow Lite. Yeah, so TensorFlow is for TensorFlow Core. Okay, so it's tf.lite interpreter. Okay, so so when we're doing inference, right, I have the file here. So if we look at the index, load and run a model in Python. You're gonna see here that we use the TFLite interpreter. This interpreter, we have, as I said, 2 ways to get, and maybe we can edit the title there. 2 ways to import the TensorFlow Lite interpreter. And in there, we have one way, which is with TensorFlow, so tf.lite.interpreter. And you can do it like this. So you will do import, so from to import TensorFlow Lite as interpreter. I think that's what you can do. All right, so this is TensorFlow Lite, or you can simply, if you do import TensorFlow as TF, you can simply do print TFLite interpreter, and you get the same thing. So we get a class interpreter. Maybe this better. From port. Interpreter. Right. Okay, here. Okay, so these. All right, so that's a different way of doing it, but yeah, so here there are different preferences, but at the end of the day, we have access to the TFLite interpreter here. And then we have the option to do it with TensorFlow Lite runtime, which is in here. Import TFLite runtime interpreter as interpreter. Right, and to do this, we actually have to install TensorFlow Lite runtime. So here, install TensorFlow Lite runtime. Okay, and then we do that. I mean, we could do it quiet, as we said before. Here we're getting the 211. So in here, the behavior is gonna differ a bit between TensorFlow 2.9 and TensorFlow Lite 2.11. So that's why actually upgrading to the latest, to TensorFlow 2.11 was something that might make sense to have a consistent behavior. 3.8, we have Python 3.8. Okay, so that's good. And now I believe if we execute this cell, no model name TFLite. All right, just lowercase. Now I'm doubting whether we actually had it installed before. Let me open. Let's do one thing. Let's scratch, delete this runtime, and skip these cells. So we're just gonna cherry pick and just execute some cells, not all of them. So reconnect. We are going to run this one and this one and this one. All right, so TFLite runtime is not existent. Okay, so we are going to put this here. So install. We need to install TFLite runtime, as it's not available by default in Google Colab as of today. I don't know if that will change, but that's what it is right now. So we're going to install here quiet so we don't see anything, and that's it. So we're going to do that, and then we'll run this code again. So this is going to be downloaded, and then we have it. Okay, so I'm not sure if we can do anything. Can we do this? Okay, so we could actually, to kind of mimic this two scripts. So we have this interpreter here. We could have the interpreter in there. Okay, so this would be TFLite runtime interpreter with lowercase. All right, so we get the same thing from two different places. And okay, so with TensorFlow core, we can directly access the TF.Lite interpreter variable. We need to install blah, blah, blah. And then with the TFLite runtime package, we can access the TFLite runtime interpreter variable. All right, so that would be, this would be how we do it. And the common practice here, so we'll do we can see. Okay, so let's put here. So we'll do import TFLite runtime, and then we'll print TFLite runtime version. All right, so we would install, and afterwards, what we see here is the versions of TensorFlow. So TFLite runtime version is 2.11. Awesome. Okay. Right. So here we load the interpreter, and actually the way we do is we would import the interpreter as interpreter, and that way, we just get the interpreter here, and we don't get the to have to do TensorFlow Lite runtime dot interpreter all the time. So once we have this, so if we do a quick recap, we've checked the versions of the things that we have by default, and then we have two ways to import TensorFlow Lite, the TensorFlow Lite interpreter with TensorFlow Core and with the TensorFlow Lite runtime, right? Let's put this as numbers, so that way we just get a list. With TensorFlow Core, we can directly access the TensorFlow interpreter variable, and then we put here 2 with TensorFlow Lite runtime. Great. Okay. So we get that, and then we access it. Okay, so we've accessed it, and now we have to make predictions with pre-trained models from TensorFlow Hub, or with models that we already have trained, or models that you train yourself. So what I'm gonna do, I'm gonna go to TensorFlow Hub. So I'm gonna open a new tab here and go to, I think it's hub.tensorflow.org. Or tensorflow.org/hub. Yes, okay. TensorFlow Hub is a repository of trained machine learning models. You can, just like this, you can download a model and get embeddings, right? For example, so this is like an text embedding model. You just load it like this, tell it to give you embeddings, and then it will give you embeddings for each of these words, right? And you have to install TensorFlow Hub. So there are many different models detecting objects in images, and there's a huge world of pre-trained models that you can use for free and that you can download that is available. We're not gonna go through everything that's available today. I'm just gonna come here to TFLite, and we're gonna look for models that run with TF2, so latest models, and that do image classification. So here, let's see what they have. Okay, let's go one by one. There are many models. It's really, it's not easy to choose. Okay, ESR GAN, super resolution model, produces. So this one, for example, upsamples images. So let's sort by architecture. So let's try to do, let's go ResNet. Let's see what they have. No. Image classification, object detection. Let's see what they have. RegNet. Feature structure pre-train, image classifier pre-trained on ImageNet 1K. Let's take a look at this. So in here, when you open the model, you gotta go to TensorFlow Lite, and TensorFlow Lite is based on this. download Apache. And we can open the model here. I'm gonna move some images from here. We downloaded this one, the object detection model, last week. So, okay, so this has the serving default and it outputs. So this is the architecture of this model that we have just downloaded. And let me see if I can zoom in. How can I zoom in here? Well, I can zoom in anyway. All right, so this is a model that outputs stateful partition call, float location, blah, blah, blah. So I guess like 1 of 1,000, so that's probabilities. One, 113. So it's an image. What's the size of the image? Let's see if we can find out what these models actually doing. Classifier, blah, blah, blah. Note the model expects images with channels last property. Height, width, batch size can be any value. Num channels batch be 3. Having pixel values in the range of 0 to 55. Note that all images resides inside the model. All right, let's not use this model because it seems there are problems with it. So let's just look for image classification and the architecture. Let's just do MobileNet v3. All right, small cassava disease, large. All right, this model is based on this. This model has automatically converted the API. The input images are expected to have color values in the range of 0 to 1, of 224 to 224. A logits vector with shape, batch size is the output. Okay, so tips for use. Image classification is a common use of machine learning. TensorFlow Lite Support. I'm not sure what this package is about. Source code for more options to configure TensorFlow L image. CLI demo tool for image classifier. Okay, let's try this demo. So this is to download the model to a temporary directory. So we'll just copy this because, well, let's actually go to the desktop and make a directory for today's live stream. And we're gonna put that here. And we're just gonna run this code. So this is gonna download the TensorFlow Lite model from the web to our temporary directory. So you can see that this is at this location. And now we're going to run the classification tool. Sparrow. All right, so let's see what it says with this image. WebP. Okay, so we're gonna convert that. What's the name? Scale web. Mogrify format JPEG scale web. All right, and we're gonna change the name of that to KiwiBird JPEG. Okay, so I do have a KiwiBird, so file that is named KiwiBird on my computer. Well, I want to stop 1 second and say hello to whoever is joining us live. Hello. Feel free to write on the chat and let us know where you're connecting from, who you are maybe, what you're interested in, and how you found us. Okay, so I'm gonna go and copy this code here, run the classification tool. We can see more about what this is. So the path is going to be kiwibird.jpg. Max results 3. Bazel not found. I don't have Bazel on my machine. Can we just do a brief install Bazel on Mac? So maybe that works and saves the day. That's gonna take some time. Okay, so is Bazel available here? Bazel version. Okay, so this now is going to start updating other libraries on my system with Homebrew. So this might take a bit. I'm gonna let it sit for a second to run the demo on. Okay, so this is nice. So this is TensorFlow Lite Support CLI. Let's see what the TFLite Support repository actually is. So this is a toolkit that helps users to develop ML and deploy TFLite models onto mobile and Internet of Things devices. Metadata populator, metadata extractor library includes both human and machine readable information about what a model does and how to use the model. All right. I'm not sure if we need the metadata version of that model that we downloaded. So you have the metadata version and the default. Let's just download here. Okay, this one has, it makes more sense. It's like a batch. You can pass a batch of images that are 224 by 224 with 3 channels RGB. It's explained here. Input image to be classified expected, blah, blah, blah. Logit vector. This is nice. So if we download this other model, so that just the TensorFlow Lite model, and we open it here, it doesn't have any metadata. This one does have metadata and license and all that stuff, which is good. Let's see if we can use this one that has the metadata in there. How is Basil going? Okay. Okay, let's keep going. Let's leave our Kiwi bird there. So do we get any examples on how to run this here? Okay, we're not going to use the support library right now. I'm just going to image input conventions. This is common, so image input. This is common to all types of image models and image signatures. A signature that takes a batch of images as input accepts them as a dense 4D vector tensor of D type float 32 and shape, batch size, height, width, and 3, whose elements are RGB color values of pixels normalized to the range 0 to 1. This is what you get from TF image decode, blah, 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 followed by TF image convert image D type, blah, blah, blah. A model with exactly one or one principal input of images uses this name images for this input. The model accepts any batch size and correspondingly sets the first dimension of tensor info tensor shape to unknown. The last dimension is fixed to the number 3 of RGB channels. The height and width dimensions are fixed to the expected size of input images. Future work may remove that restriction for fully convolutional models. This statement means that fully convolutional models might behave in a way that I'm not sure if it's parametric inside, but that it doesn't have a fixed width and height that you have to input to it, that you can simply input an image of whatever size you want, and then it will resize and do the operations as it needs to be. Consumers of the model should not inspect the shape directly, but obtain the size information by calling hub get expected image size on the model or model spec, and are expected to recite input images accordingly, typically before during batching. For simplicity, TensorFlow Hub models use the channels last or NHWC. So this is num for batch, num height width channels layouts of tensors, and leave it to TensorFlow's graph optimizer to rewrite to channels first. Num of the batch, channels, height, width if needed. It has been doing that by default since TensorFlow version 1.7. Okay, so I think we might have a full example here that we might be able to use. Note that this example uses random noise, like just a randomly generated image to comply with the input shape. So we don't load and resize an image, but we just generate an image on the size that we want. And that is just to make sure that the workflow works and so on and so forth. So here they're using NumPy and TensorFlow. Let's actually get started writing some code. Let's see if Basil, so this hasn't installed yet. All right, so we will import here NumPy as MP as well. And I'm gonna put this to my side screen and I'm gonna be writing this code or rewriting the code here with you so you can follow along. Okay, so let's just make this big so you can see it. Great. All right, so all we have, let's see how this is going. Okay, all we have is, so this is a hands-on example of the inference. So we're going to be using that example that I showed before. Let's do everything here. So we first load the TFLite model and allocate tensors. We can do, for example, that our interpreter is going to be the TFLite runtime interpreter, right? And we load from model path, and then we put here path to model, which we don't have yet. All right, so let's actually set that here. TFLite model path. So let's just write that here, and we're gonna put it here to content and whatever we have, wherever we have it. And we have to actually download, we can download pre-train dot, okay, .tflite model directly from TensorFlow Hub. How do we do that? We just add here the curl command that we were taking a look at before and just change the URL. Curl L TFLite model URL, and we're gonna save it as TFLite model path. So we will put that above, and we'll put the URL variable here as well. And if you go to TensorFlow Hub, you can see that they provide this download button, but if we copy link address, we're gonna get the URL that is needed to download that. So you can see that in large here, the entire URL in here, right? So we're putting is TensorFlow Hub Dev, Google Light Model, ImageNet, blah, blah, blah. And this flag here is light format TFLite. Let's actually make sure that we're getting the one with metadata. Nope, we're not. So I'm gonna do that again, and I'm going to paste it again. All right, and we will, maybe, all right, let's just leave this generic name and try to download. So if you go to this icon here, you can see the files on the notebook, and you can see that actually that model file is being created. And hopefully that worked properly. It seems it downloaded the 20.9 megabytes of the model, and download the model from TensorFlow Hub with curl. All right, and now we can load the model here. So we just need this variable, and we just need to call interpreter allocate tensors. All right, so we run this piece of code, model object is not callable. All right, so we have imported interpreter here. Let's run this code, and let's see if just by putting here interpreter, if we can do that. Let's print here echo TFLite model path. Let's see what that is. But we can actually just put this here like that. Okay. Interpreter. So TFLite runtime interpreter. Well, let's try it this way. Let's see. Okay. Let's try this. Module object is not callable. I see. Okay. Okay, so this was important here. So this is meant to be like this, and then we're meant to do this. Okay, so this is something I was trying to look for before. So we have here the TensorFlow Lite Python interpreter, and here we have the TensorFlow Lite interpreter. So this interpreter that we have here right now we don't need to redo this here. We can simply do here TensorFlow Lite interpreter, capital case, and load that. All right, and that works. So this code now is fully working, and we can proceed and continue with our example. All right, allocate tensors. So we get the input, so get input and output tensors. So we're going to get the input details and the output details, and we'll actually print them. So input details and output details. And in the input details, we have interpreter, get input details, and the same for output details, and then we print there. All right, so these are my input details. So we have a serving default inputs. That's the one input that we saw before as num of channels and HW channels, right? And then we have the stateful partition call, which is going to be a batch of like all the classes that exist on the output classes, right, on the data set. All right, so we continue and we say, okay, test the model on random input data. This is what we loaded NumPy for. So if we put this here, we can say, okay, input shape is going to be input details 0 shape, and this we get, you can see that is the right one. Input data, MP array, and then here we do MP random sample of that input shape, and the D type is going to be MP flow 32. So input data, we get this, and we can actually print the shape. So we see it's going to be 224 by 3, and we actually have this. So this outer side here is actually making this into an array, and we get that data and set it set the input tensor. So interpreter set tensor input details 0 index, and then input data. All right, so we do that. So we're setting that tensor, and what has happened is that we've set the slot. So we set the input data into the slot where it has to go. We allocated the tensors, and now we're going to invoke, right? So when we do interpreter.invoke, we actually invoke the model. Nothing that we can see, but the model has run. And now we need to get the output data. So the interpreter get tensor output details 0 index, and then we print that output data. I'm gonna copy here. So get tensor returns a copy of the tensor data. Use tensor in order to get a pointer to the tensor. All right, so that's a good note. And let's add some credit here. The following example is based on, and we put the link here. TensorFlow's official TFLite inference guide. Right, when you put that here, and credit where credit is due. All right, so I think, let me do one thing really quickly. So the camera has been running from its battery for the last hour. So I'm trying to switch it on now that I've plugged the battery. I forgot to do that beforehand. All right, let's keep going without camera and see what's going on here. And I'll switch on the camera in a second. All right, so we're gonna execute this one here to obtain the output data. And then here we get a classification. So we get, if we get the output data shape, we're gonna see the, so this is the shape of the, this is the shape of the output tensor. We input one image and just a batch with one image, and we get a batch with just one set of results. And from here, I guess we'll just do, I think we can just do argmax output data. Let's see, 736. So that would be the index of the class that has the highest score in the resulting matrix. So like we do output data 0 and we do 636, we see that 7.21 is the highest logit. So we need to see, now we need to make sense of those, of that result, because what we're getting here, as the model is saying, is a logits vector, right? So we can turn logits vector into probabilities. Okay, so logits, TensorFlow, sigmoid. So I guess we can do prediction, TensorFlow, softmax, and then we get this one. Let's see. Got a batch. Okay, let me, oops, output data. Let's just do, apply this to the batch, and then we can do prediction 736. Let's see the probability. 30%. So if we actually print the entire array of results, all right, so let's say we say predictions are this, and then we can do predictions sort, and then we get the predictions, we get the first one, and we get the last one. So do this and do that. Oops. Okay, what's going on here? Oh, okay, so maybe we need to do this. So this. All right, so now, great. So this is the highest, right? So this is the highest. Reverse true. So now we're getting the highest probability is this one. That is the one that belongs to this, right? So it's 30%. We're getting that one, and the latest, like the lowest, is this one. All right, so that means that it's working. I mean, if we were to do here print np argmax for prediction, we still get 736. Okay, so that means, yeah, that's good. That means that this is working. So we okay, so let's see what this function is actually doing. Softmax, computed softmax activations. Logits vector, apply softmax to the logics to get probability if needed. Okay, so this is what we just did. And they have the labels, output tensor metadata, labels.txt, which I'm not sure where that file is. Subgraph metadata. That would be good if we can get that. Right, let me turn on the camera again. Right, I'm back here now. All right, so to that example, I think okay, so right now what we've done is use random noise. So we actually need to change that code to load an image. So let's see, where do we get a sample image? Are there sample images in here? All right, so let's take this sample image so that we have here. Okay, let's clean up this a bit. So we have the output data and we don't need this. We have the softmax use. So what this describes here, let me put the sample input image, sample image URL in there. and then we also download that sample image with curl. Sample.jpg, and we're just gonna copy those sample image URLs, sample path, and we do that, and you're gonna see that we're gonna download hopefully that image. Oh, okay, so let's just put it at content. All right, we have sample, we can open it here and see that it's indeed the apple that we were talking about. Okay, so we have that image, and now we have to load that image. Test the model on random input data. What this describes in here is that we're applying softmax to the logics vector to get probabilities. So we're apply logits. So this is softmax to the logits vector to obtain probabilities, and output data. So this is predictions, and here we can actually get the, let's do one thing. So let's see, can we do this? Can we put like an actual batch of data here? Okay, let's leave this for now as it is. All right, invoke output data predictions, and then here we get the argmax predictions. So if we made, what happens if we replicate, we just repeat this item here? I'm curious. If we put two items, we put an array of items here. Okay. Let's just leave this as it is, and let's do input a real image into the model. All right, so for this, we have to use TensorFlow image decode JPEG, and then we have the to sample image path. All right, so we print the image and sample image path. Decode JPEG. Oh, okay. Yeah. So we actually need to do TFIO read file, I think. Sample input path. All right, so that loads the image. We could display it, but we're not going to display it right now. And we would have now to do what was being said. Input. Where was that page? Image input. Okay, so TF image convert image D type. So TF image convert image D type, and then we get the image, and then we say TensorFlow float, was it 32? All right, so now it goes from 0 to 1, and we can use this as an input to the model. All right, load the image from file, decode as JPEG, and convert to float 32, 0 to 1. Okay, so this works. This is loading an image properly, and then we can input this into the model. So we can now I'm not sure we need to allocate tensors again. Let's just try not to do that. So we would basically, now we have an image here, so we can do image shape, and this is definitely not what the model needs. Let's see. Size must be a 1D tensor of 2 elements. Input shape. Let's see what input shape is. All right, and there you go. You get an image on that size. And then we can say inputs. Input batch could be TF expandems of image in axis -1. So input batch size. Oh, shape. All right, not that one. Okay, yeah, 0. Okay, so num height with channels, and I'm gonna just put here, because I think that's how it is. So if I put here 200, okay, yeah, so that seems like it's about right. All right, so we create, turn the input image into a batch of 1. Okay, so now we do have a batch that we can input as an input batch tensor. And now what we're gonna do is what we did before. So let's delete empty cells that we don't need anymore. Set the tensor. So we'll just do the same that we did here. So interpreter set tensor input details index. And now we have this input batch, this new data. And we will call here interpreter invoke. And then we do the same thing that we did before. So we output the data, and then we get the predictions. Okay. we repeat the steps above to set the input tensor with the batched images, invoke the model to predict, then get the output data, and then apply softmax to the logits to obtain probabilities. All right, so we do that, and now we have the predictions variable here for the new image, and we do np argmax for predictions. We're gonna get one class that is 479, and now we need the list of classes, the labels txt, but I'm not sure how to get usage data. Let's see. I guess like this is a separate thing. It's like, how do we get the access to the metadata? Okay, let's take a look. Let's see how to access TFLite model metadata. Deep dive into the image classification example. So we have metadata, but how do we read it? Input metadata FB. Okay. Metadata display with model file. Export JSON file. Okay, metadata. Where is this metadata coming from? TFLite support. Okay, so okay, so we install the TFLite support Python package with pip, and we do here pip install TFLite support, and we're gonna do here quiet for the quiet flag. And I guess in here we can use this code just from TFLite support. So we'll do from TFLite support. So pips can do, but you have. Okay, let's do here upgrade, and we'll put here TensorFlow just to see if that works. And here I'm just gonna get, okay, import metadata as metadata. And let's see if that works. See that I'm upgrading to TensorFlow 2.11 again, so I'm not sure how that's gonna play, but that's what it is. Okay, we don't need this anymore for now. I don't think we need this, and this is to create metadata, but I'm gonna go straight right now. So let's take a look. Let's put this source here, and what we want to do. Okay, so this model. Okay, so what model is this? All right, and okay, so this seems like it has imported metadata. And now that we have metadata installed, we're going to read it. So let me put this on the side and type the code so we don't just copy paste. Okay, we remove this and we say here, okay, so you can use Netron to visualize your metadata, or you can read the metadata from a TensorFlow Lite model into JSON format using the metadata displayer. All right, let's add a note here. So this is a quote from this page. So we're gonna add the source link here. Metadata, I have to say, it's something new for me. I have never used it before, like TensorFlow Lite metadata, but it seems really useful. So the displayer is gonna be this metadata displayer, and we're gonna say with model file, and then here we're going to load our, so let me see. And then we have our TFLite model path. Okay, let's see if this executes. All right. So we're going to do export JSON file, OS path. We haven't imported OS, so I'm just going to do that here. Import OS and flags, export directory. Where is that flags coming from? We got to look at it now. Was path, split text, model base name, 0 plus .json. I guess we can do this like this. All right, so this is just trying to get the model name with JSON. So I'm actually gonna do it differently. I'm just gonna do here TFLite replace TFLite for JSON, so we don't add more complexity to this script. Join export directory. We don't need this, so we just can do this. Let's see if this works. What we want. So you just want to get model.json. Yeah, okay. So that's gonna work, and we're gonna do JSON file is gonna be displayer get metadata JSON, and we just have to write it to a file. Displayer. All right, and we'll do here with open export JSON file as a write, as F. We do F write JSON file. All right, so we're gonna write to a file, and then we get this model.json here. And we can see that this is all the metadata that we have. Input tensor metadata, process units, labels for objects that the model can recognize, tensor axis labels. And what I'm interested is in seeing how to access this data. Input image to be classified. This is really nice. I mean, we've got metadata versioning. How do we get associated files? The metadata extractor library is a convenient tool to read the metadata and associated files from a model across different platforms. It says we can unzip it. I'm not sure if that's something I can do here. Yeah, I guess it's metaphorically. In Java, pass the name into the metadata extractor get associated file method. Okay, so metadata, so TFLite get associated file in Python. So let me bring this here. How to load, blah, blah, blah. Metadata documentation. Well, let's see the API. So here we have this player. So let's see. This player. Wait, so the class that it's mentioning it's metadata extractor. So let's see if we can do extractor equals metadata displayer dot get as get backed associated file list. All right, nice. And then here displayer get packed associated file list. No, get associated file buffer. Labels.txt. Right. Right there. So this is a file buffer. TensorFlow file buffer. into file buffer. What does that really mean? Can I simply write that to a file? Let's see. Export labels file. Right, let's see. Okay, so we write that. Oh, doesn't write right arm and string, not bytes. Okay. File buffer bytes to string TensorFlow Python. Let's see what decode. All right, that worked, and we're getting the labels. All right, so if we do that, maybe we can even just display them here because we're decoding, and we could split by break line, and we can get. All right, so I'm gonna stop. We're gonna continue on this, but I'm gonna stop now, and I'm just going to get so we have here the prediction index is this one, and we have 479. So we're gonna get the prediction index, and on this list, so we're gonna get like this as labels, and we're just gonna put this here. I don't know. All right, and we're gonna get the labels, and what we're gonna do is we're gonna say labels prediction index carton and car wheel. All right, so maybe something's wrong in what we're doing. I'm not sure. $479. Let's actually take a look at this file locally. Okay, so we said 479. 479. Let's see. 479. doesn't have the Apple class, does it? Let's see if we get 5 predictions. All right. Let's get another image. Let's just try. Let's see also what classes are here. Banana. Okay, so let's get an image of a banana. So we get this. And we go replace the sample image. All right, so we download that image and we're re-downloading the model right now. And we've downloaded this banana image. Okay, so we're going to, so we have that path. We're gonna reload the model and allocate tensors. We're gonna get the input details. We're going to, so this is to pass through the random shape, which I'm not gonna do right now. I'm going to load directly that image. We're gonna make a batch and we're going to grab this, and then we get the predictions. And then for the prediction index, we get 692. Which is 956. So 692 is Oxcart. I'm not sure what's going on here. Might be good to preview that image. Let's try really quickly here. All right, so the image seems good. So let's print the output data to see if we're getting something. That is really weird, actually. Seven, 2 running shoe. Something is not properly set with how we're decoding the results or inputting the image. So I'm going to leave it here and I'll try to debug this offline and we'll see. But so you get an idea. This is the type of notebook that I'm trying to do during the live streams, right? So we are gonna have an index of content, something that we covered, and people are gonna be able to, after they, if they've missed the live stream, like if you get that link that is on the if you get that link that is on the live channel, you're going to be able to follow along everything that we've done. So I'm going to copy this link that I've put here. I'm going to open an incognito window so you can see that anyone is able now to browse through this notebook and read through the notes that I've put there. And it's not quite working yet, but it will. So we're going to change this for visualize TFLite model metadata. Yeah, so we have to finalize this, and there are a few things that are not quite there. If I were, let's see, if I were to download this image and input it to the model by drag and dropping, what happens? Banana. All right, so something is not right, and I'm not sure what it is. What is it? If you know, put it in the comments. If it might be a silly thing, I just need to take a look. Okay. Okay, let's actually reset this thing. Hello, Bea. And this other thing. All right, so let's not output anything here. So this is supposed to be working now. And let's see if we get the same class prediction. Same thing. All right, so we're gonna wrap it up. We're gonna let it sit for a bit. I'm gonna try to solve this offline, but you have the notebook there, so you're able to browse through everything that we did today, and hopefully we find that little issue and everything works pretty soon. So thanks a lot for connecting live, for those of you who were live. Thanks for watching after the fact. And I would say like the video to support the work that I'm doing here. And don't forget to subscribe if you want to get notified when I go live next, or when I upload new videos or new podcast episodes. Thanks a lot for watching. It was Nono Martinez Alonso here. I encourage you to watch other videos on the channel, and I will see you next time. Bye.